In question number 6a, by sketching a suitable pair of graphs, you have to show that the equation modulus x minus 2 is equals to 2 sine half x has only one root. So the way to do that would be, let's make the x and the y axis first. Now, if we have to sketch a graph of y equals to modulus of x minus 2, we can first simply sketch the graph of y equals to x minus 2. So assuming y values of x and y, when x is 0, y is minus 2. When x is 2, y would be 0. So 0 and minus 2 is over here, let's say, and 2 and 0 would be over here. So the line would be like this. But as it's a modulus sign, so the final answer would be this part where we'll only consider the blue line as the graph. And this part below the x-axis will cancel out due to the modulus sign. And now sketching the graph of y is equals to 2 sine half x from 0 to half 0 to pi, basically 0 to 180 to understand it better. So now first taking the x value as 0. So when x is equals to 0, y would be equals to 0. Then we can take x equals to, let's say, pi by, so this is already 1 upon 2. Let's take it as pi over here. So if I take the value of x as pi, what I will get is y is equals to 2 sine of pi by 2. Sine 90 is 1, so the y would be equals to 2. So this point was, I think this point was 2, and pi means 3.142. So let's say if this is 2 over here, 3 is over here, and this value is 2 over here, and what we are getting is 2 over here as well. So the graph would be, the graph for 2 sine half x would be like this. As there would be this half x also we can understand like this. Uh, in 360, we'll have one revolution for sine x. So if it is half x, we'll have half a revolution in 360, or we can say even a quarter revolution in 180. So this is the only part that we will be making. And we can see that there's only one point of intersection from 0 to pi. And we cannot go beyond pi because, well, the domain is given from 0 and less than pi. So this point basically shows that there is only one solution. Now it says show by calculation the root lies between 1 and 1.5. Now we can write our equation as modulus of x minus 2 and then minus 2 sine half x equals to 0. Please first substitute x is equals to 1 over here. So 1 minus 2 would be minus 1 with the modulus sign minus 2 sine of half. And then this will become positive 1 minus 2 sine of half. So this will be 1 minus 2 sine of, and the bracket will have 1 upon 2 in radian form. And this will be 0.04. So this answer is coming out as 0.04. And now substituting 0.5 over here, we'll get 1.5 minus 2 sine of, the x value is 1.5. So that will be 1.5 upon 2. So this will become minus 0.5, but with the modulus sign, that will be a plus 0.5. So 0.5 minus 2 sine of 1.5 upon 2. And we are getting minus 0.86 in this case. So this change of sign basically means that the root lies in between 1 and 1.5. So we'll write change of sign from, it was initially positive to negative, when over here x was equals to 1 and negative 1 when x was equals to 1.5. Now in part C, it says use the iterative formula with an initial value of 0.1.03 to calculate the root correct to two decimal places. So this is the easiest step. All we have to do is substitute the first value. We know that is 1.03. So that will be 2 minus 2 sine of half into 1.03. Now substituting this in the calculator, we'll get 2 minus 2 sine of 1 upon 2 multiplied by 1.03. Close the bracket. And the answer for the first answer is coming out as 1.0149. And now we'll substitute this back again into the equation, and we have to give all of our iterations to 4 decimal places. So substituting this back into the equation, we'll get 1.0149 And now the third value would be 1.02809. So that will become 1. And then substituting it back into the equation over here, we'll get 1.0281. And now we are getting 1.01658, so 0.0166. Again, substituting it back at, so 0.166. So now we are getting 1.0266. And we have to make sure that we get our answer correct to two decimal place. So substituting this value back in 0.0266, and we are getting 1.01789, so 0.179. And we have to show enough iterations to show that the answer is coming correct to the same correct two decimal place consecutively. So 1.0254, actually the difference between two consecutive values is decreasing in every step. 0.0255, substituting it back in over here, we will get 0.255 over here. Now this is 1.0188, 884, so 0.0188, and then substituting it back again, 0.0246, 1.02469, so 247. Now it's 1.0195, 0195. So basically, to two decimal place, the answer will always be 1.02. You can just do it one more time to confirm. So if I put 195 over here, it will again be 1.0240. So what we can see is from 241, this will become 241. So we can see each time the all of these values are decreasing, or this value is increasing towards 1.02, and this is decreasing towards 1.02. So the final answer for x would be x equals to 1.02.